In this video, we're going to start the KutaSoftware Infinite PreAlgebra free worksheet, Factors and Factorization. Our instructions on this first page are to list all positive factors of each. What exactly is a factor? Now, positive factors are whole numbers that can be multiplied together to get the same product. And that product that we're looking at in number 1 is 30. Now, how I like to do my factors is I like to start out outside to inside. So right away we know that 1 divides 30. So I'll write a 1. And 1 times what gives us 30? Well, that's 30. So I know 30 is the biggest thing that divides itself. So I'll write that all the way on my right hand side. And I'm going to leave a little bit more room because I know there's a lot of numbers that will happen. The next number is 2. 2 divides into 30. 2 times 15 gives us 30. And then the next number that multiplies, well, 1 went in, 2 went in, and 3 also goes in. 3 times 10 gives us 30. Does 4 multiply into 30? Nope. The closest things to get to 30 would be 4 times 7, which would be 28, or 4 times 8, which would be 32. So we can't get to 30 there. Let's try 5. Oh, 5 goes into 30. 5 times 6 gives us 30. And now, if you see, there's not a whole number in between 5 and 6, which are multiplied together to give me 30, that I can find. So my factors in number 1 are 1, 2, 3, 5, 6, 10, 15, and 30. Let's move on to number 2. In number 2, we have 22. So right away, I'm going to start by writing my outermost factors. My smallest factor is 1. My greatest factor is 22. Now what else goes into 22? Let's try 2. And 2 goes into 22. Well, because 22 is even, but 2 times 11 gives us 22. Now, does 3 go in? Well, if we remember from our divisibility video, because 2 and 2 add up to give me 4, that's not divisible by 3. So we know it's also not divisible by 6. And 4 isn't divisible by 9. So 3 doesn't go into 22. 4 does not go into 22, because 4 times 5 would be 20, and 4 times 6 would be 24, so we missed 22. 5 doesn't go in because it doesn't end in a 0. 6, we already said, doesn't go in because 3 doesn't divide. 7 does not go into 22. 8 does not go into 22 because 8 times 3 would be 21 and 8 times 2 would be 16, so we skip over 22. 9, again, doesn't go into 22 because the digits aren't divisible by 9. And lastly, 10 doesn't go into 22 because it doesn't end in a 0. So we only have the factors 1, 2, 11, and 22. And if you're confused on how I'm figuring out divisibility by adding the 2 digits, check out my video I did where I talked about the divisibility of numbers. I'll leave a link in the description below so you know how to access that video. But for now, let's move on to number 3. In number 3, 1 and 28 are our smallest and greatest factor. And then from there, this is even, so I know that 2 divides into 28, and that'll be 2 times 14. And then I know that 3 doesn't divide into this because 2 plus 8 gives me 11, and 11 is not divisible by 3. Now the next number in question would be 4, and 4 times 7 gives me 28. So now I have to see, is there a number between 4 and 7 that also divides 28? If there's not, I'm done. So 5 doesn't divide 28 because it doesn't end in a 0 or a 5, and 6 doesn't divide into 28 because it wasn't divisible by 3. And in order to be divisible by 6, it has to be divisible by both 2 and 3, which this number is not. Therefore, the factors of 28 are 1, 2, 4, 7, 14, and 28. In number 4, we have number 16. So 1 and 16 divide, and then it's an even number, so 2 will divide into 16, and that's 2 times 8. 3 does not divide into 16 because 1 plus 6 gives us 7, and 7 is not divisible by 3. 4 does indeed go into 16, and that's 4 times. So there's no whole number in between here that divides, and 4 is redundant, so when we list out our factors, we only write 4 once. 4 goes into 16 4 times. So our factors in number 4 are 1, 2, 4, 8, and 16. So the neat thing about factors is that we're going to have an even number of factors for all numbers except when we have a perfect square, because a perfect square is a number times itself. So for in this case we have 4 times 4. Those are the same factors, so as opposed to writing them twice, we write it once. That'll give us an odd number of factors. Another one would be something like 3 times 3, the number 9, or 5 times 5, 25. Let's see if any of those appear later in our video. But for now, let's go on to number 5. In number 5, we have the number 60. I know that it's divisible by 1. 1 times 60 is 60. I know that it's divisible by 2 because it's even. 2 times 30. I know that it's divisible by 3 because 6 plus 0 is 6, and 6 is divisible by 3. So that's going to be 3 and 20, because 3 times 20 is 60. I know that it's divisible by 5 because it ends in a 0. 5 times 15 gives me 60, and I also know that it's divisible by 6 because it was divisible by both 2 and 3. So 6 times 10 will give me 60, and now I just have to look between these two numbers, 6 and 10, to see if anything else divides into 60. Does 7 divide into 60? No. Does 8 divide into 60? Nope. 8 doesn't divide into 60 either. How about 9? The easiest way to know if 9 divides into 60 is to add 6 to 0, which gives us 6, and if 6 is divisible by 9, then 60 is divisible by 9, which it's not. So 7, 8, and 9 do not divide 60. Therefore, I have all my factors listed out. 1, 2, 3, 5, 6, 10, 15, 20, 30, and 60. Let's move on to number 6. In number 6, we have the number 87. So right away, we can find two factors. That's going to be 1 and 87. Now I have to ask myself, does 2 divide this? And no, it does not, because it's not an even number. Well, how about 3? 8 plus 7 equals 15, and 15 is divisible by 3. So 87 is divisible by 3. 3 times what gives us 87? And that's going to be 3 times 29. Now I have to see, is there any other number that divides into 87? Well, 4 does not. 5 does not, because it doesn't end in 0 or 5. 6 doesn't, because it wasn't also divisible by 2, even though it was just divisible by 3. 7 does not divide into this. 8, no. 9, it does not add up to be divisible by 9. 15 is not divisible by 9, so 87 isn't divisible by 9. It's not divisible by 10, because it doesn't end in a 0. And if you want to keep checking all those other factors, think about two numbers that are very close together that multiply to give us something close to 87. So there's no other number between 3 and 29 that multiplies to give us 87. So 1, 3, 29, and 87 are my factors for number 6. And again, you don't have to check every individual number between here. You just have to check enough numbers to know that something towards 29 does not get multiplied by something towards 3 to give us 87. And the more you practice with factors, the more comfortable you'll get in finding those limits and finding where you can stop. But for now, let's continue on to number 7. In number 7, we have 68. So right away, I know that's 1 and 68. 68 is even, so I know that 2 goes into it. So 2 is a factor, and 2 times what gives me 68? That's going to be 2 times 34. So now I have to ask, does 3 go into this? 6 plus 8 equals 14, which is not divisible by 3, so 3 doesn't go into it. Let's check 4. Does 4 divide into this number? Yes, 4 does. 4 times 17 gives me 68. I know it's not divisible by 5 because it doesn't end in 0 or 5. I know that 6 can't divide into it because the number isn't divisible by both 2 and 3. 7 does not divide into it. 8 does not divide into it. 9 does not divide into it. 10 does not divide into it because it doesn't end in 0. And I know the rest of my numbers will not divide into it between 4 and 17. So 1, 2, 4, 17, 34, and 68 are my factors for number 7. For number 8, I have 99. So it's going to be 1 and 99. Those are two factors I can start with. Now, 2 doesn't divide into 99, but 3 does because 9 plus 9 equals 18, which is divisible by 3. So that's going to be 3 and 33, because 3 times 33 gives me 99. 4 does not divide into this, and we don't even need to check because 4 is an even number, and an even number times any other number is always going to be even. So because this isn't even, I can eliminate out 4, but remember, just because a number is even does not mean it's divisible by 4, but it means 4 is a possibility. When we have an odd number, 4 isn't even a possibility. So not 4, not 5 because it doesn't end in 0 or 5, not 6 because it wasn't also divisible by 2, 7 doesn't go into it, 8 doesn't go into it, again, for the same reasons that 4 doesn't go into it. Let's try 9. 9 times 11 will give us 99. So the only number in between that is 10, and 10 times 10 is 100. So we know that these are our only factors. 1, 3, 9, 11, 33, and 99. In number 9, we have 85. So I know that's going to be 1 and 85. It's an odd number, so it's not going to have any even factors. So that right away eliminates 2, which therefore eliminates 6. But it's divisible by 5 because it ends in a 5, and that's going to be 5 times 17. No other number divides evenly into 85, so the factors are just 1, 5, 17, and 85. Let's move on to number 10. In number 10, we have 72. So I know 1 and 72. 72 is even, so 2 divides into it. 2 times 36 gives me 72. Now 7 plus 2 equals 9, so I know it's divisible by 3. 3 goes into 72 because 7 plus 2 equals 9, and 9 is divisible by 3, so that's going to be 3 times 24. Now the next number in question will be 4, and 4 does go into 72. 4 times 18 gives us 72. So the next number in question, 5, it doesn't end in 0 or 5, so it's not divisible by 5, but it's divisible by 6 because 2 and 3 both divide 72, therefore 6 has to divide 72. And 6 times 12 gives us 72. And I know that 9 divides into 72 because 7 plus 2 is 9, and 9 divides 9, so that's going to be 8 and 9, because 8 times 9 equals 72, and there's no other number left in between to check. So 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72 are my factors of 72. In number 11, we have 96. So 1 and 96 is where we'll start. Then it's even, so I know 2 goes into it. 2 times what gives me 96? That's 2 times 48. Now I have to check if 3 divides into it. And I know it does because 9 plus 6 gives me 15, and 15 is divisible by 3. So 3 times what gives me 96? That's going to be 3 times 32. Now I'll check for 4. Does 4 divide into 96? 4 does indeed divide into 96. 4 times 24 equals 96. Now we're going to check 5. does not work because it doesn't end in 0 or 5. 6 will work though because 96 was divisible by both 2 and 3. So 6 times what gives us 96? That's 6 times 16. And then there's only two other factors that go into this. 7 doesn't go into 96, but 8 goes into 96. And that's going to be 8 times 12. 8 times 12 gives us 96, and in between 8 and 12 would be 9, which doesn't work because 15 wasn't divisible by 9, 10, which doesn't work because it doesn't end in a 0, and 11, which doesn't work. So 1, 2, 3, 4, 6, 8, 12, 16, 24, 32, 48, and 96 are the factors of 96. Now in number 2, we're looking at 74. So right away, that's 1 and 74. It's even, so 2 divides into it. 2 times what gives me 74? That's 2 times 37. Now 7 plus 4 equals 11, which is not divisible by 3. So 3 doesn't go into 74. 4 doesn't go into 74. 5 doesn't. 6 doesn't because it wasn't divisible by 2 and 3. 7 doesn't. 8 doesn't, and so on. So checking all my numbers, 1, 2, 37, and 74 are my only factors of 74. Now on to number 13, 86. It's divisible by 1 and 86. It's also divisible by 2. 2 times 43 gives me 86. 8 plus 6 equals 14, which is not divisible by 3, so that eliminates a lot of other things. That eliminates 3, 6, 9. It's not divisible by 5 because it doesn't end in 0 or 5. I know it's not divisible by 4, so I can check a few others, but 1, 2, 43, and 86 are my only factors of 86. Now for number 14, we have 75. So this is the last problem on this first page of the worksheet. If you've been finding this helpful so far, give me a thumbs up, subscribe to my channel, and share this with somebody else that you think will also find it helpful. But for now, let's do number 14. 1 and 75 divides 75. 2 doesn't divide 75 because it isn't even, but let's check to see if 3 does. 7 plus 5 equals 12. 12 is divisible by 3, so 75 is divisible by 3. 3 times what gives us 75? That's 3 times 25. And then 4 isn't because it's not even. 5 does because the number ends in 5, and that's going to be 5 times 15. And there's no other number between 5 and 15 that divides 75. So 1, 3, 5, 15, 25, and 75 are my solutions in number 14. Now continuing on to the next page, our directions are to write the prime power factorization of each. Now, what exactly is the prime power factorization? Well, basically what we're going to do is we're going to break this number up into things that multiply into it. But we're only going to have prime numbers written that multiply to give us 48. So right away, what two numbers multiply to give us 48? That's a 1 and 48, but that won't help us because 1 isn't prime and neither is 48. But 48 is even, so that's going to be 2 times what? 2 times what gives us 48? That's going to be 2 times 24. So 2 is a prime number, but 24 is not. So we're going to break 24 up. What multiplies to give us 24? I'll leave my 2. That's going to be 2 times 12 gives us 24. So now I have a prime factor 2, another prime factor 2, but 12 is not prime. So I got to keep going. What multiplies to give us 12? 12 is going to be 2 times 6. So again, I have a prime factor, a prime factor, a prime factor. 6 is not prime. So I'm going to break that one up as well. So writing all my prime factors, 2 times 2 times 2 times 6 can be broken up into 2 times 3. So now you can see that I have a prime factor, prime factor, prime factor, prime factor, and another prime factor. 2 is prime, and 3 is prime, so I have all prime factors. So now I'll simplify. How many 2's did I have? 1, 2, 3, 4. So this is going to be 2 to the 4th times 3. So I've written 48 as just prime factors multiplied together. Again, 2 times 3 is 6, times 2 is 12, times 2 is 24, times 2 gives me 48. 2 to the 4th times 3. Let's try another one. Let's go over to 16. 16, I have 35. So I know the factors are 1 and 35, but 35 in itself isn't prime, so let's keep digging. 2 doesn't go into 35, 3 also doesn't, 4 doesn't, but 5 does. 5 times 7 gives me 35. 5 is a prime number, and 7 is a prime number. So 5 times 7 is the prime factorization of 35. And if you're confused on what a prime number is, a prime number, just to reiterate, is a number where the factors are 1 and itself. So 2 is only divisible by 1 and 2. 3 is only divisible by 1 and 3. 4, see, 4 wouldn't work because that's divisible by 1, 4, 2, and 2. So 4 wouldn't work. So we'd move on to 5. 5 is divisible by 1 and 5. So that's prime. 6 would not work. That would be 1, 6, 2, and 3. That wouldn't work. The next one would be 7. That's divisible by 1 and 7. 8 wouldn't work because 8 is also divisible by 2. 9 wouldn't work because 9 is also divisible by 3. 10 wouldn't work. It's even. We know it's divisible by 2. 11 would be next. That's just 1 and 11. And then after that, the next prime number would be 13. And we know we can discount, we know that we can count out all the evens. So let's just go through odds. Well, 15 is also divisible by 3, so 15 wouldn't work. 17 would work. 17's divisible by 1 and itself, and that's it, and so on. So there's lots of different prime factors. So just try to find those numbers that are only divisible by 1 and itself. That's what makes it prime. So let's continue on now that I've quickly reviewed that. So here we are on to number 17. So we know that 1 and 46 isn't prime because it's an even number that isn't 2. 2 is one of my favorite numbers because it's the only even prime number, which is pretty awesome. So 2 divides into 46. 2 times what gives us 46? That's going to be 2 times 23. And if you notice, 2 is a prime number and 23 is also a prime number because the only factors of 23 are 1 in itself. So we have the prime factorization. 2 times 23 gives us 46. Moving on to number 18, we know that 40 itself is not prime because it's divisible by 2. 2 times 20 gives us 40. 2 is a prime factor, but 20 is not, so we're going to have to break it up even further. 2 times, what can we write 20 as? 20 is 2 times 10. So we have prime factor of 2, prime factor of 2. What other prime number goes into 10? Well, 2 times 2 times 10's even, so 2 goes into 10 as well. And that'll be 2 times 5. So now we have prime, 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 and another prime. So we have 2, 1, 2, 3 times. So that will be 2 to the 3rd times 5. There we have the prime factorization of 18. And again, how I like to break this up is I like to start with my smallest prime numbers that go into it and work my way up. In number 19, we have 100. 100 is 2 times 50. Rewriting my 2 because that's my prime number. 50 can be broken up into 2 times 25. So not only do I have my 2 that's prime, 2 doesn't go into 25, but I know my next prime number would be 3. 3 doesn't go into 25, but 5 goes into 25. So I'll have 2 times 2 times 5. 5 times what gives me 25? That's 5 times 5. So I have all prime factors remaining that are multiplied together. So that's going to be 2 squared because I have 2 2's times 5 squared because I have 2 5's. So 2 squared times 5 squared gives me 100. 2 squared would be 4, 5 squared would be 25, 4 times 25 gives me 100. Moving on to number 20, we have 66. And 66 isn't prime because I know that it's definitely even. So 2 goes into it. How many times does 2 go into it? 33 times. So I have a prime number 2, but 33 isn't prime. I know that 33 is divisible by 3. So I'm going to have 2 times 3 times 33 is 3 times 11. So now I have prime number 2 times prime number 3 times prime number 11. That's my prime factorization. 2 times 3 times 11. So we can see that 3 times 11 gives us 33, times 2 gives us 66, or we could do 2 times 3, which is 6, times 11, which also gives us 66. That's my prime factorization. On to number 21, we have 75. It's not divisible by 2, but it is divisible by 3. So my smallest prime factor that goes into it is 3. And that's going to be 3 times 25. Now, 3 is prime, but 25 is not. So I'll rewrite my 3, and that will be multiplied by, what's the smallest prime number that goes into 25? That's going to be 5. 5 times 5 gives me 25. So here I have my prime factorization, which is 3 times, there's 2 5's, so that's 5 squared. That's because 3 is prime and 5 is also prime, and I have 2 5's, so that's 3 times 5 squared. In number 22, I have 72. 72 is divisible by 2. 2 times what gives me 72? That's going to be 2 times 36. So I have my prime number 2, and 36 is even, so I know that 2 still goes into that. So I'll rewrite my 2. 2 times what gives me 36? That's going to be 2 times 18. So now I have prime number 2, but 18 is not prime. 18 is still divisible by yet another 2. 18 is 2 times 9. So I have prime number 2, and 3 of those are multiplied by 9. But 9 is not prime. It's also not divisible by 2. So I'll have 2 times 2 times 2 times 9 is divisible by 3. That's going to be 3 times 3. So now I have all prime numbers remaining. So I have 3 2's, so that's 2 to the third times 9's, which is 3 squared. 2 to the third times 3 squared is my prime factorization of 72. In number 23, I have 65. It's not even, so 2 doesn't go into it. 6 plus 5 is not divisible by 3, so 3 doesn't go into it, but 5 does, because it ends in a 5. 5 times what gives me 65? That's going to be 5 times 13. And I know that 13's prime, so 5 times 13 is my prime factorization in number 23. In number 24, I have 81. Now I'm going to do this one slightly different because 81 I know is 9 times 9. So I didn't actually break it up into prime factors first, I just split it up into smaller numbers to work with. And I know that 9 is divisible by 3 and 9 is divisible by 3, so I'm going to rewrite this. 9 is 3 times 3, so I'll have 3 times 3 times 9. So I have primes, and then again 9 is divisible by 3, so 3 times 3 times 3 times 3. I have all prime factors, 4 3's, so 3 to the fourth is my prime factorization of 81. So sometimes it might be easier to break it up into smaller numbers to work with. But you could have done it the way we've been doing it, saw that it wasn't even, so it wasn't divisible by 2, but 8 plus 1 is 9, and 9 is divisible by 3, so we could have pulled a 3 out at the start. In number 25, we have 80, and I know that it's even, so it's divisible by 2, and that's going to be 2 times 40. So prime number 2, 40 is still even, so I'll do 2 times 2 times 20, because 2 times 20 gives me 40. So now I have two prime numbers, 2 and 2, but 2 still goes into 20. 2 times 2 times 2 times 10. 2 times 2 times 2 times 10, because 20 equals 2 times 10. 10 is still even, so 2 times 2 times 2 times 10 is 2 times 5. So now I have all prime factors, 1, 2, 3, 4 2's, so that will be 2 to the 4th times 5. 2 times 2 times 2 times 2 is 2 to the 4th, and I'll multiply that by 5. That's my solution in number 25. Another way we could have gone about doing this, though, is we could have recognized that 80 is, well, let's just split it up into the greatest prime number that goes into it. That's going to be a 5. I know that 80 is 5 times 16. So I have my prime number 5, and 16 is divisible by 4 and 4, which 4 is divisible by 2 and 2. So right there, I have my 4 2's and my 5. So there's a couple of different ways of going about prime factorization. Stick with what's easiest for you and what makes sense. Let's move on to 26. 26 is 54. It's even, so I know it's divisible by 2. 2 times what gives me 54? That's going to be 2 times 27. But if that was hard to realize, let's look at 54. I know that 9 times 6 gives me 54. So I'm going to write this as 6 times 9. I know that neither of these are prime factors, but I'll split these up individually. 6 is 2 times 3, so that's 2 prime factors, and 9 is 3 times 3. So because 6 is 2 times 3 and 9 is 3 times 3, I have all prime factors now. So this is 2 times 3 cubed. And again, 3 times 3 times 3 was 27, and 27 times 2 gave me 54. So again, sometimes it's easier to break it down into smaller numbers first, and then find the prime factors of those. Especially when dealing with larger numbers. Now 972 is even. I know that 2 goes into it, but how many times? I'm going to take 972 and divide it by 2. 2 goes into 9 4 times. 4 times 2 is 8. So I'll have 1, bring down my 7. 2 goes into 17 8 times. That's 8 times 2, which is 16. Then I'll bring down my 2. 2 goes into 12 6 times. So that's 486. And I know that 486 is still even. So I have one prime factor, and I can break up 486. 486 is even and divisible by 2. 2 goes into 4 2 times, 2 goes into 8 4 times, and 2 goes into 6 3 times. So I have 2 times 486 is 2 times 243. So now I have 2 primes, but 243 isn't prime because 2 plus 4 plus 3 is going to give me 6 plus 3, which gives me 9. And because 9 is divisible by 3, I know that 3 divides into 243. So let's go ahead and do that math. I'll have 243, and I'll divide that by 3. 3 goes into 2, 0 times, so 0 times 3 is 0. I'll subtract 2 minus 0 is 2. How many times does 3 go into 24? That's 8 times. And then how many times does 3 go into 3? That's 1 time. So 3 goes into 243 81 times. So now I have 2 times 2 times, breaking up 243 into 3 and 81. 3 prime numbers now, but 81 is divisible by 3 still, because 8 plus 1 equals 9, and 9 is divisible by 3. So I have 2 times 3 times 81 is divisible by 3. 3 times what gives me 81? Or really, if you want to think of 81, 81 is 9 times 9. So let's go ahead and write 9 times 9, because those will be easier to work with than 81. So now I have 2 times 3 times 9 times 9. So I can write 9 as 2 prime factors multiplied together, and that's 3 times 3. So rewriting this 9 as 3 times 3, and then rewriting this 9 as 3 times 3. Now I have all prime factors. So let's take a look. I have 2 2's, so that's 2 squared, times 1, 2, 3, 4, 5 3's. So that's 2 squared times 3 to the 5th. 2 squared times 3 to the 5th is my solution in number 27. And another way I could have done this problem is when I got to 243, 2 plus 4 plus 3 equals 9. I could have realized that it was divisible by 9 here and divided this by 9 first, which then I could have broken up as 3 times 3. So regardless of how you do it, as long as you keep track of your numbers and those prime factors that create those factors of your original number, you'll get to the prime factorization. Let's move on to our last problem on this worksheet, number 28. Now in number 28, we have 660 that we're trying to see the prime factorization of. So 660 is kind of intense to work with, so let's break it down into smaller numbers. 660 ends in a 0, so I'm going to break that up into 10 times 66. Now I know that 10 can be broken up into 2 prime factors. That'll be 2 times 5, and I'll multiply that by 66. So I have 2 prime factors, 2 and 5, and 66, I know, can be broken up into 6 times 11. So I'll do 2 times 5 times 6 times 11. So now I have 2 and 5 as primes and 11. 6 is not though. 6 can be broken up into 2 times 3. So I'll have 2 times 5 times 2 times 3, which is 6, times 11. Now I have all prime factors. So I'm going to rearrange to make sure that my smallest prime factor is first, and that occurs 2 times. So 2 times 2 is 2 squared. Then I'll multiply that by 3, then 5, and then finally 11. 2 squared times 3 times 5 times 11 is my solution in number 28. And what's unique about prime factorization is that every integer has its own unique prime factorization. So no other integer will be able to be factored like this. But with that, we wrap up our free factors and factorization worksheet from the KutaSoftware website. I'll leave a link to this worksheet in the video description below. If you have any questions, put it in the comments below. And as always, don't forget to like, subscribe, and share. If you want more ways to support me, become a patron. Go ahead and check out my Patreon page. Until next time, happy learning!